3A. Yes, we are. Mr. Edlin will be super stoked.
He was like telling us maybe this is like why I should be going to this.
I know. He came by and asked me why too. I told him just to go back to Hall B. Just kidding. Can you imagine? No, I didn't. All right, derivatives. So we know what the derivative is. We know how to find the derivative two ways, by taking the limit as h goes to 0 and also taking the limit as x goes to a.
3 ways.
But we're going to learn, yes, the shortcut, as you guys like to call it. 3 ways? What's the, oh, on your calculator. Good call. Okay, here we go. Number 1. Yeah, but it's a lot. We're learning a lot today. First of all, there's a constant rule. Constant rule. Okay? So here's the constant rule. It says if f of x is equal to some constant c, then f prime of x equals, what is the slope of a tangent of y equals a constant? 0. Okay? So the derivative of all constants is 0. So for example, if you have f of x equals 14, okay? And you were told to find f prime of x. You don't have to go through the whole limit process anymore. The derivative would be 0. Okay? All right, number 2. Here's what you guys like to call the shortcut. This is called the power function rule. It deals with exponents, because a lot of times we like to take derivatives of polynomials. Because a polynomial is a curvy thing, and we want to find what the rate of change is at one point, so we want to take the derivative of the polynomial. So we use the power rule. And here's what the power rule says. It says, if f of x is x to the n, okay, then f prime of x is, and a lot of you guys know this already, you bring the n down to the front, times x, and then you subtract 1 off of the exponent. That's very powerful. It's huge. There's big proof for that, but we don't need to learn it. You're okay. That's going to be a lifesaver, right? So for example, like on your quiz right there, we have f of x equals 3x squared, okay? What's the derivative of that? You can find it super fast now. Bring the 2 down. 2 times 3 is 6, and subtract 1 off, it's 6x. Okay, remember when I was talking to you about all parabolas, the derivative is a line, and then the derivative of a line is 1, or the slope, sorry. Okay, this works also for things that, what's that?
That's just the rule.
That's the rule. So let's do another one. Let's do f of x equals negative 10x to the 5th power. And I want to find the derivative of that. So the rule says, this is like a formula, it's a rule. Take that 5, bring it down and multiply, negative 50, and then subtract 1 off. That would be the derivative, negative 50x to the 4th. Without having to do the limit process, that's so much better, right? But things that you don't think are exponents are exponents. So for example, if we had, bless you, f of x equals 2 over x. Do you remember finding the derivative of that? Remember x plus h minus f of x all over h, and it was horrible, and you had to get a common denominator and flip the h and blah, blah, blah. This now, what you can do is you can write it in exponential form so that you can use the power rule. Exponential form of this would be 2 times x to the what? Negative 1, right? Because that's the exponent. You bring it up, becomes negative. And now do the power rule. Take that negative 1, move it down, becomes negative 2, and then subtract 1 off of the exponent. What's negative 1 minus 1? Negative 2. And we want to rewrite this without negatives in our answer, negative exponents. So negative 2 stays there, x squared. Do you remember getting that answer when we would do that every single time?
No.
Thank you, Trevor.
That was like negative 1/4.
I remember
Yeah, it was like, yeah, because then you plugged in like 2 and you got negative 1/4 because it was like at x equals 2 and you'd plug it in. But that was like, we would go through the whole limit process and that was our answer at the end. But now we have this power rule. Okay, another one is f of x, sorry, I know I gotta stop, huh? F of x can't stop, won't stop. Rad x. Okay, rad x. You think, well, that's a radical. How am I gonna use this shortcut with this? Well, it's also an exponential function, or not an exponential function, but you can write it in exponential form. This is x to the 1/2. Okay? And so when I take the derivative of this, I bring the 1/2 down to the front, subtract 1 from 1/2. Don't forget to do that part. I was helping a girl yesterday. She's really good at these, but she kept forgetting to do that part. So subtract 1 off, and it's negative 1/2. And then, you know, this looks pretty ugly, and we got to fix it. Here's where your algebra skills are going to be really important. This right here becomes 1 over 2. And this x to the negative 1/2, x to the negative 1/2 is really 1 over x to the 1/2, which is really 1 over rad x. Okay? So this becomes 1 over 2 rad x, and you do not need to rationalize your answer. We did that too. We did the limit as h goes to 0. You don't need to write this down. But we did rad x plus h minus rad x all over h. We worked it all out, and we ended up getting that at the very end. But now we have that. We did that one. Do you remember? Oh, you do remember that one. Good. Yay. Okay. I already talked about the coefficient rule. Oh, another one of these. Let's say you have a lot. We have so many to do. Say you have y equals x to the 7th over 5. That bothers people. They think, oh, this is division. That looks weird. No, all this is this is just 1/5 x to the 7th. Okay, that's the same thing, right? Do you agree with that? Yeah, but it looks kind of weird. And when you take the derivative, it's just the same rules that you've done, that you're doing today. Bring the 7 down. So what's 7 times 1/5? 7/5. And then subtract 1 off the exponent. So good, right? Okay. All right. That was, sorry, the power, that's all we've learned today, you guys. That's the power function rule. And now we're going to go with number 3. Number 3 is the sum and difference rule. Sum and difference rule. Okay, the sum and difference rule is not going to be the same as the product or quotient rule. So this one is the easy one. The other ones that are coming up are a little harder. Okay, it says if f of x is equal to a plus or minus b plus or minus c, and a, b, and c are all different power functions, okay, then the derivative of this is pretty basic. It's just to take the derivatives of all these separately. A prime plus or minus b prime plus or minus c prime. Okay? I'll show you an example of that. And you're going to be like, yeah, duh. All right. So let's say that we have, I know I wasn't labeling my examples today as numbers, but so that you don't know how many we do. Let's say, yeah. Let's say we have f of x equals 2x to the 4th plus 3x squared minus 5. Okay? So there's a big old polynomial for you, and we're going to take the derivative. Oh, man, that would be so mean if I made you do the limit as h goes to 0 on this. That would be terrible. I wouldn't.
Thank you.
You're welcome. Yes. So now we have this power rule that says we can take the derivatives of all these individually, since they're plus or minus. So this would be 8x to the 3rd plus 6x, and then derivative of negative 5 is 0. Okay? Oh, let me teach you something else. Then what you can do is you can take the second derivative. You do? Yes!
Why do you keep going?
Because the first thing is like the motion. The first, what did I do? Take the derivative of negative 5 is 0. Derivatives of all constants are 0. In physics, it's like you have the first f of x is the motion. Then you take the derivative and you find out that's what? Velocity. You take the second derivative and that's what? Acceleration. And usually you stop there, but yeah. So the second derivative would be what?
24x squared plus 6.
Perfect. 24x squared plus 6. And then you can take the third. Actually, I think there is a third derivative in physics. It's the jerk.
What is the need for this?
48x.
Because we can.
What's 48x?
Yes.
Why would you do this? Now 48.
What's the fourth derivative?
Snap.
48. And the fifth derivative? 0. I changed to Roman numerals.
I saw that.
Can you?
I think so. I think they do. I don't know. Okay, now let's suppose, here's our example.
What number is this?
What number is this? Whatever. Okay, let's do this. We're going to find the horizontal tangents. Yeah. We're going to find the horizontal tangents of y equals 4x cubed minus 6x squared minus 1. Find the horizontal tangents. What in the world does that mean? Okay, now you're at a point where, and then, like, for example, I was helping that girl yesterday, and she's like, she get to a problem, she's like, take the derivative. And that's all, like, you really start by taking the derivative all the time now. It's funny. No matter what the problem's asking, it's like, okay, I have to take the derivative, probably. And you do. So we're going to take the derivative here. And the derivative of this would be 12x squared minus 12x. And then the derivative of negative 1 is 0. Okay? So bring the 3 down. 3 times 4 is 12. Subtract 1 off. 2, subtract 1 off. We're good. Now, horizontal tangents means that the slope is what? 0. So we're going to set the slope, which is y prime, equal to 0 and find out what our x values are. So 0 equals 12x squared minus 12x.
Why do you have to take the derivative before you do all of this?
Because the derivative is the slope of the tangent. So if I know that the slope of my tangent is horizontal, I know the slope of my tangent is 0, so when I take the derivative, I can just plug 0 in and solve. Now, do you know how to solve this? You can factor it. Factor out a 12x, and you're left with x minus 1. So x would be 0 or positive 1. Yes? And so my horizontal tangents would be at the points. Take 0, plug it back into your function.
The derivative function or the?
No, you need y. So this is x and y. You don't want y prime. Y prime is not the y value here.
The negative 1.
So you get negative 1, and then take 1 and plug it in, and you get 4 minus 6 minus 1, negative 3. Okay? And you know what we just found? This is so cool. This right here is a third-degree polynomial, right? Looks like that. We just found the maximum and the minimum of it. Without graphing, without, no, you don't care? Like so? No, it's so powerful, right? It is. Like, one more of these. Watch. If you have y equals negative 2x squared plus 4x minus 3, okay? And you learn in Algebra 2 how to find the maximum of that without graphing, okay? You have to find the vertex, the maximum. My Algebra 2 kids, they would do x is negative b over 2a, right? Do you remember that? Okay, without your calculator, right? Your calculator would do it for you. Right, yeah, or find the maximum, right? Calc maximum. But now what you can do is you can take the derivative of this thing. And you get negative 4x plus 4. And if you want to find the maximum, that would be where your tangent is horizontal. So you would set this equal to 0 and solve. So you'd add 4x, and you get x equals 1. And then you take 1 and you plug it back in, Negative 2 plus 4 is 2 minus 3, negative 1. So now you know how to find the vertex of a parabola without doing x is negative b over 2a, without completing the square. Remember completing the square and finding it that way, putting it into vertex form? You can do it by taking derivatives now and using calculus. Isn't that so awesome?
No.
I'm the only one that's excited in here about this, but that's okay. All right. Oh, is that it? Really? No, I was going to teach product and quotient rule. Okay, and then tomorrow we will do the product and quotient rule. So practice these today. Thanks. Bye.